Hello everyone, this is Revathi working as an assistant professor in information technology from SNS College of Engineering. Today we are going to see about Floyd's algorithm using dynamic programming. Floyd Warshall is a dynamic programming based algorithm, so it breaks the problem into smaller subproblems and then solves each subproblem. After that, it combines the result to solve the bigger problem while storing the result of each subproblem for future reference. Let's have a discussion with our students. Thank you.
Hello, thanks for the opportunity. It's my pleasure to introduce myself as well as my teammates. Well, my name is SNS and my teammates' names are Varun, Abhirami and Kirtana. In this video, we are going to make a more elaborated version of the content for the case study video of Floyd's algorithm using dynamic programming. So first, I will give a little introduction of our topic. Um, Fluid's algorithm is a powerful technique for solving all the pairs of shortest path problems in the graph using dynamic programming. In this video, we delve into the intricacies of the Fluid's algorithm and explore its applications. Next, we are moving to the dynamic programming concepts. Well, in this dynamic programming is a problem-solving technique that involves breaking down the complex problems into simpler subproblems and also solving each subproblems only once and storing the solutions to avoid the redundant calculations. So this approach is particularly useful when the problem exhibits overlapping subproblems on optimal substructural properties. Next, we are moving to the topic called Fluid's algorithm overview. So Fluid's algorithm is a classic example of the dynamic programming applied to the shortest path problem in the graphs. It aims to find the shortest path between all the pairs of the vertices is in weighted graphs, and unlike other algorithms like Dijkstra, Bellman-Ford, which focus on finding the shortest path from the single source to all the other vertices. Fluid's algorithm computes the shortest path between all the pairs of vertices simultaneously. So further topics will be explained by my teammates.
Hi, my name is Varun. Now I am explained about four steps involved in Floyd algorithm: initialization, dynamic program iteration, updating distance, repeat iteration. Initialization. Beginning by initialization, a distance matrix to represent the direct edges weight between vertices. Set the distance between vertices; they are not directly connected to infinity. The matrix will be gradually updated to store the greatest distance between all pairs of vertices. Dynamic program iteration. Iterate through all vertices of the graph and consider each vertex as the potential intermediate vertex, the shortest path between two other vertices. By considering all possible intermediate vertices, we can systematically explore and update the short path between all pairs of vertices. Repeat iteration. Continue the dynamic programming iteration until all vertices have been considered as the potential intermediate vertex. At the end of process, the distance matrix will contain the shortest path of between all pairs of vertices. Updating distance. For each pair of vertices u and v, compare the current shortest distance between them with intermediate vertex k. If the path of through vertex k is shorter, update the distance matrix accordingly. Repeat this process all pairs of the vertices and intermediate vertex. Next.
Hello everyone, this is Kirtana. I'm going to explain about optimizations and complexity. While Floyd's algorithm is conceptually simple, there are several optimizations that can improve its efficiency. One common optimization is to stop the iterations early if no improvements can be made, reducing unnecessary computations. Additionally, techniques such as memorization can be used to store and reuse intermediate results, further speeding up the algorithm. Despite this optimization, the time complexity of Floyd's algorithm remains O of V cube, where V is the number of vertices in the graph. Application and use cases. Floyd's algorithm has numerous applications in various domains, including network routing, transportation planning, and traffic optimization. In network routing, for example, it can be used to find the shortest path between all pairs of routes in a network. Optimization, data transmission, and minimizing latency. Similarly, in transportation planning, it can help identify the most efficiency routes for the vehicles to navigate through a road network, reducing fuel consumption and travel time. Thank you.
Hello everyone, this is Abhinami. So here we're gonna take a deeper look with a real-time example where we apply Floyd's algorithm and dynamic programming concepts. So the example is GPS navigation. Here we consider city road networks as the graphs and the intersections are the vertices and the roads are the edges with the weights that represents the intersections. So here we apply Floyd's algorithm. This involves by initializing the matrices that stores the shortest path between the intersections, and we are repeating this process until we get the shortest distance. At each step of this algorithm, we are dividing the problem of finding the shortest path into sub problems. So this helps us to find the shortest path in a faster way. During this process, we may encounter many overlapping solutions. For example, when we find the distance between A and B via the intermediate intersection C, we may encounter many solutions between the paths A and B. By completely understanding this Floyd's algorithm and the dynamic programming concept, we can able to tackle a wide range of optimization problems in various domains. And we hope this case study video will help you to understand this algorithm and the programming concepts. So